Thank you.
Oh. And today, what are you going to talk about?
Well, we've been talking about pets. So this is
Mhm.
our Pets for Health and Longevity Part 3. And new things are coming up all the time. So we just keep adding. We could do Pets 500, I suppose, but there are other things, fun things to talk about too. But so I'll go ahead and start my PowerPoint.
Okay.
And it looks like it came up and everybody's happy. Now we'll see if my pointer wants to work. That's always fun. Oh, it does. Okay. So we're going to kind of go back to the beginning. And what I am going to do today is do a little bit of a brief summary of what we covered in parts 1 and 2 right at the beginning here. So if people are interested to go back and look at those. And of course, you have to go to Critical Health News on most of the platforms and then type my name in, Dr. Judy Reynolds, right after that, and it should pull up the ones that I've done in the past. But there, whatever is the easiest way for you to do that. I usually just go to Facebook when I want to watch the replays and do it that way, but there are many ways to do it. So we need to go back to the beginning here. And Dr. Linus Pauling, two-time Nobel Prize winner. He was famous for his work on vitamin C, talking about how important vitamin C is. And I did cover that extensively in my water-soluble vitamins and vitamin C talks from a while ago. So you can look those up also on whatever platform you use. But his famous quote, nearly all disease can be traced to a nutritional deficiency. And this is the basics of epigenetics. In other words, we don't just blame our genes and our parents for everything that goes wrong. Any what they call disease state where something isn't working correctly, people used to think ever since they figured out the genome and all these things, okay, let's blame it on the genes and there's not much you can do. Well, we now know that's not true. Basically, your genes are going to give you things like basic height, hair color, and eye color, things like that, color of skin. Those are because of, that is a genetic lineage that we get from our parents. But what we don't get is a gene for diabetes or a gene for a bunch of these other names of things that they've come up with when we have a bunch of symptoms. So what we do as nutritionists, we feel like the nutrition, making sure we get all the nutrients we need, we call them essential nutrients, making sure we get all the ones we need is the way to get our bodies to do what they're intended to do. If you think of any kind of a machine, the machine needs all of its parts and it needs all of its lubricants and gasoline if it's a car, oil in the engine, all these kinds of things. So if we think of our human body sort of that way, even though we are much more glamorous and complex than any machine so far. And I know people may want to argue with me about that, but I'm ready for that argument. But anyway, we have to have all the parts that we need. And sort of, for some reason, through education, we've kind of stopped teaching people what real food is and what our bodies actually do. And as I've been an educator, I started teaching community education classes and 4-H classes and things like that before I even had kids of my own. And before I went to college to get the degrees that are listed on this beginning slide of this talk. So I have always been interested in learning and teaching. And it's just, people aren't learning these things. And so what I do is try to bring us back to basics. If you didn't have all the parts to build what you wanted to build, how can you expect that whether it's a machine, an animal, a human, or whatever it is, how do you expect it to work? We don't. So this is where we're at. We're saying, hey, let's get the parts in there that need to happen. And you can see that he was born in 1901, died in 1994. And this picture is in one of Dr. Wallach's books. But I'm telling you, a good book to go and look at is called How to Live Longer and Feel Better. It's a 1986 book by Linus Pauling himself. So this has been known for a long time that we need to make sure we get all our nutrients. So that it's not something new. Okay, so in the first part of feeding our pets, these are the main topics that I covered. Start with essential nutrients, how important that is. Like I was talking about with Linus Pauling. I talked about mineral interactions, about how important it is that things have to fit together. We have to have the right ratios of each of the nutrients. And we know we need at least 90 essential. In other words, they have to come in your diet. They're things that you cannot make yourself within your body. You have to get it in your diet. So we talked about that. Then we talked about NRC and nutrient requirements. And at that time, I didn't even have the newest pet nutrition book, which I got before we did Pets Part 2. So I'll talk about that more in a minute. But I went through what are National Research Council nutrients for humans and horses. And we went through that. So you had the basic understanding. Another big concept we talked about is when you look at the amount of each nutrient by having the correct amount, and I mean not just enough to not obviously be sick, but to thrive, an optimal amount. And we compare that, the health and performance, to the amount of nutrients. That's a key thing that I talk about a lot. I gave an example then about epigenetics. Again, epi means above. Genetics means what's in your actual genes. And I gave the example from Dr. Wallach's book about cleft palate in foxes. And what happened was there was a pair of foxes, and I believe it was in a zoo, and they had a litter of kits that all had cleft palate. And what that is when an animal body is forming, it starts out kind of as a flat plane, and then it curls up and joins in the middle. And that's how we get the outer layer of our skin and then all the things that are inside of it. That's a normal way to form. But when all the nutrients aren't there for the mother and possibly the father, that doesn't close completely. And that's how you get cleft palates and spina bifida and a bunch of these different disorders. And so we talked about that as an example. So Dr. Wallach proved that it wasn't genetic because he did a basic experiment where he inbred. In other words, he took the father, mated to the daughters, and the mother mated to the sons, and did that with 100 and some foxes. And by giving them, the example he used is he actually fed them dog food, which was fortified with vitamins and minerals, and they had no cleft palates in the offspring, 100 plus offspring. So he proved, no, it wasn't that the parents were defective. It was that the food given to the parents didn't allow the kits or baby foxes to be formed. And then we did some fun pet stories. So if you want to go back and watch that episode, you can see that. Then in Summary of Feeding Pets Part 2, then I actually had the NRC nutrient requirements, the newest one of dogs and cats. And it isn't real recent. It's 2006. The one that I was involved with reviewing was in 2007. That was the most recent version of the NRC horse. And so the thing is, you're talking 20 years in between these things being updated, and you can imagine how much information is coming out in between. But I did quite a bit of information on basic things on how to feed your cat and dog from that book. So go back to Part 2 for that. Then I did a comparison of GI tracts or digestive tracts, and we looked at the dog, the cat, the pony, and the sheep. So what happens there is the dog and cat don't have a big fermentation vat at the back. They just basically eat food. So it's questionable how much fiber they need. That was a big takeaway from that. The pony has a huge cecum or fermentation vat and colon, bigger than any other animals. And I mean, that's the one that I studied the most, the horse. And then the sheep has it's what we call a ruminant. So they have a multi-compartmented stomach. And then they also have bacteria in their colon, but they don't have that huge cecum like a horse does. So we compared all those. And it's important to look at what the tract is like and how it works to decide what's the best food. So it makes sense if the animal has a way to ferment fiber, like a ruminant in the stomach or a horse in the cecum and colon, then it makes sense that they are fiber digesters. Their main food that they eat is grass. However, not so with the cats and dogs. So we need to do that differently. We talked about body condition scoring. And what that is use pictures to show it, but it's basically how do we know if our animal is too thin, too fat, or just right? And that has to do with the storage of fat. It doesn't tell you about the protein or vitamin mineral status. It only tells you fatness. But it's a huge thing because when we're trying to decide how much to feed an animal, we need to know, do we need to keep the weight they have? Is it just right? Or do we need to give them more food for more weight or less food for less weight? I did talk about pet food safety and household poisons. So that's one that we can go back and look at, and we will mention that again in a few minutes. Okay, I talked a little bit about non-nutritive food additives, and the point there was that things that we put in foods and feeds, so-called preservatives. And I gave an example of BHT, BHA, and ethoxyquin. And those were preservatives that were approved back in the 1980s and 90s. We don't use those anymore. They literally are not used because they're artificial and they have been found to cause problems. So now the main one we use is vitamin E. A little more about that in a few minutes, but vitamin E is huge because it's the only quote preservative that keeps foods fresh, mainly as an antioxidant, but it's also nutritive. It has nutritive value, huge nutritive value. And I was lucky enough to work where some of that information was coming out about the vitamin E and how important it is. And then we did our amazing pet rescue stories with certified holistic health coach Andrea Rickards, who happens to be my daughter. And she told us about some literally pets that were basically dying. They had no future. Two of them were in kidney failure. And with specific protocols and care that we do, she works routinely with a veterinarian with a nonprofit rescue, and I work as the nutritionist for them. And all of us get together, and this is what we do. And the thing is, if we can figure out how to fix some of these animals that are in so severe shape, it makes sense that we can then know how to take better care of our animals even when they're not in such bad shape. So this is kind of where we do a lot of learning. That was my favorite episode because my daughter was on with me. Okay, so now this is that nutrient requirements of cats and dogs. And just going back again, this is kind of the review of what we did last time. It is the most current issue. We talked about digestive anatomy and physiology and compared those digestive tracts. We talked about hormones and how they affect whether your pet will eat or not. And then we talked about factors affecting digestibility. And that's huge because we all know people always used to say it's what you are what you eat. But no, you are what you eat and absorb and can utilize. And those are two different things. So it's digestibility. And then we talked about how there are feeding recommendations, again, back to the humans, the horses, the pets, all of them. There are feeding recommendations, but they're complex. And so someone needs to help interpret them for you. That's the main thing that we come across from there. Okay, so I was very excited a week or two ago. I couldn't believe it. I'm always going out and looking for what's new as far as books. And the reason I like to do books is because the information is usually really well cited and it's permanent. So someone that's on the internet that writes something, if they decide to change it and upgrade it, that could be a really good thing. But if they just want something to disappear because they don't like it, that is not a good thing. And so when I have all this library of books, I've talked about many times, I'm a third generation library person, but I found this book, 2026. It's the second edition. I didn't even know there was a first. 797 pages. But what's fascinating about this book for me is that Dr. Wu was mainly the protein metabolism professor at Texas A&M when I went there. I started in the fall of 1990, and he came as his first major position to Texas A&M in 1991. And I did research with him in protein metabolism, and I was planning to do my PhD research in the field of proteins. I was fascinated by them. It's what I wanted to do. But what happened was there was this brand new horse disease that had taken the whole horse world by storm. Horses were literally dying overnight in their stalls. There were all these problems. And I ended up taking that up as my research project, and I did that instead. But Dr. Wu has become literally famous. I remember a few years back, they give awards for all of the land grant universities. And that means land grant means they're working with agriculture and animals. And Dr. Wu and another Texas A&M professor who I was not there at the same time, he's there, but the other one won the best, and Dr. Wu won the second best scientist of all the land grant universities in the country. And I can't, I mean, I'll have to read through all the things he's done because it's fascinating, but pretty cool that I got to be taught by him. And he was one of my committee members on my Master of Science degree. So he was actually one of the people that worked with me to do that project. So, what does it say about this book? It says the authoritative reference for academic researchers, practitioners, and beginners in the fields of animal and human nutrition, biomedicine and allied health, as well as institutional and government policymakers. Okay, this is the type of thing that people who are rewriting our nutrient requirements and things for government policymakers and institutions and all these kinds of things, this is the type of book that is needed. And so, again, I was so excited about it. It's going to take me a long time to go through it, but I did pull some things out and I'm going to, continue to do that. But the huge thing here is you notice it says animal and human nutrition. Try to find one of those. Try to find a book that has both. Texas A&M is one of the few universities, I think there were maybe two in the country that does both. So in the animal science department, where I got my master's degree, the College of Human Nutrition is included in the animal science department. So when I got my degree in nutrition and when I got my master's in animal science, all of this, it's all together. So I got to learn from a Dr. Joanne Lipton, who was a top human nutritionist at the time. And I got to learn some genetics. I did genetic labs, things like that. So the point is, I learned about Linus Pauling when I was very young, and I was interested in human nutrition. But then my passion was horses. So this all ties together. It's extremely important that we learn from all these. In nutrition, we need to learn from all these different species because they react differently. So this is why it's such a huge thing. And Dr. Wallach is one of the few people who also did both animal as a veterinarian and human as a naturopathic physician. And, his pig pack and things like that he did started out in animal and then went to human. So just pulled this back up from the other talk to show you that there are these old books. And this is how we find out the actual research and the citations are in these books. Whereas something online, you really half the time don't even know if it's true. Say nothing about, how biased is the source and this kind of thing, which is a huge thing for me. Okay, so back to digestion of foods by dogs and cats. Okay, so each nutrient, a protein, an amino acid, vitamin E, whatever, in each food is digested by specific pathways. That's biochemistry. It's very complex. For people like me, it's fascinating. It's more than most people want to deal with. But the thing is, every time we change the amount or ratio of ingredients, everything changes. The digestibility changes. Everything changes. And this is why we need to have these manuals like the National Research Council, nutrients of each species and all this, because someone has to put all that together. Now, in Dr. Wu's book that I just talked about, it's just a huge expansion in the last 30 years. And you can imagine the last maybe 10, maybe less than that, we've had artificial intelligence. And what he was able to do with that book, and he talks about it, he talks about artificial intelligence being able to put everything down. But he does not use the artificial intelligence, and neither should we, to ask its opinion, because that's what it is. And it's not a true opinion. It's just gathering stuff together without understanding as a human being what's going on. So he used it for that. But he summarized everything himself. He would take each study, and by the way, he's got hundreds of his own studies in there, but also many, many other people. And so here's my caution again about where are you getting your information? If you want to find the so-called truth, we need to go to the actual research, and then we have to be able to interpret it ourselves. There's another thing that's come out recently that I worry about, and it's called the meta-analysis. And you've probably heard of those, where they will say, well, we took 500 studies and, 34,000 people. We put them all together in meta-analysis and we found out XYZ. Why is that a super, super, super bad idea? Because all the specifics have been lost from each study. You don't know how many were in there. You don't know how they were taken care of. You usually don't have a really good idea of even the protocol that was used. You don't know what exactly was in the diets because they're not all the same. And then conflicts of interest are completely lost. The first thing I do when I want to look at a research paper or a book of research papers, I look at if the references are there, if they're complete, and I look on the study itself on conflicts of interest. Because I did mention this in one of the previous talks about, I gave an example of if I was trying to sell an oil, and let's just do an example of canola oil. All of the oils that are mechanically and then chemically taken out of that plant, the processes used denature or change the molecular shape of the things that are inside of it. And so if a person is doing a process like that, but their goal is to sell it, the goal, capitalism, you take something that someone else might want, you make it, you put a price on it, and it sells according to the market. So all of that's fine and dandy. But if you're reading a source by that company that makes that money, it should be divulged in the conflicts of interest section in that research. Now, there's one caveat that, as I go through and think about this stuff, I always think, well, I don't think I made that super clear. Yes, that happens all the time, but that doesn't mean that someone who is really good and ethical and, works for a company is not giving you something important. And I'll give you an example of that, and that is with coconut oil. There's a doctor by the name of Bruce Fife, and he wrote multiple books. He was hired to do it. But when you go through and look, his research is true and real. And so someone has to interpret that. How do you know if someone is just, has a conflict or they're doing this, but what they're doing is real? So that's another thing that I do and that nutritionists do. So coconut oil was misunderstood because when they demonize saturated fats, it's a very, they call it a medium chain saturated fat, but it has wonderful benefits. Baby formulas, the same basic fatty acids are in breast milk. So, I mean, there are wonderful things about it, but it was misunderstood. So, okay. Watch our sources. Okay, that's a huge thing. Now, I wanted to do this, and again, it may be a little hard to read because just the way the colors are together. I don't know how big it is on your screen. If it's on your TV, you can probably see it fine, but it's a concept slide. We have indigestible fibers, which is in purple here. We have fermentable fibers. In other words, the bacteria in our body or our protozoans or some other animal can ferment it. We have our fats, our protein, and our sugars and starches. So when we look at this, the stomach here, these are just rough. They're not shaped any certain way other than to do the concept. What happens is each of these different types of nutrients goes into the stomach. then the small intestine, then the large intestine, and then out in the feces or whatever it's called, manure in that particular species. But I want to show you what typically happens with these different nutrients. Okay, indigestible means that it won't be digested, so it goes out, all the way out. That's it. The fermentable fibers are supposed to go to the large intestine, and then theoretically, they should be digested by bacteria, and the result is what we call volatile fatty acids. In other words, 2, 3, and 4 carbon short little fats. Okay. But the fermentable fibers are actually strings of sugars. Again, that's for previous talks if you want to go back and review that. But they're little tiny fats. That's what we get. Then our actual fats go through the stomach, small intestine. Towards the end of the small intestine, they should be absorbed. And by the way, just to orient you, this is the bloodstream. Anything that comes out here with these arrows right here, this is coming into the bloodstream. Where over here, it's manure. It stayed in the digestive tract. Okay. So for our fatty acids, we want them to go into the small intestine where they're virtually 100% digested, unless we super overfeed. And if we do that, we can get a little bit of it making it through here and going out. And that's when you would have a loose or fatty stool in a pet person, cat, even horses. It can happen. Then we have our proteins, and for the most part, they should be broken down the small intestine and come out as amino acids into the blood. But again, some of them are going through, and in that respect, it's a good thing because some of them are actually going to feed those bacteria that live back here. And then the bacteria also create protein, and some of that will go out. So you'll have a little bit of protein lost, amino acids lost, but you do get the amino acids here in the blood. And then last of all, our sugars and starches should go through the stomach into the small intestine and pretty quickly become blood glucose, or as we know, depending on which sugar and starch it is, you might have fructose digested differently, things like that. But this is basically what we're looking at. This is what's trying to happen. And then it's going to make a difference which kind of each one of those things we do. So again, that's a basic concept of digestion. And since I'm going to bring up a little bit of a new topic here today, enzymes. This is something that I've talked about in the past, but sometimes people think that they want to add a vegetable oil. And again, for the most part, vegetable oils are bad because they're denatured. They're not good. It's better to use the whole plant, or except in the case of coconut oil and maybe a couple others. But when we top dress something like that, say for instance, you had a pet food and someone told you it was a good idea to add some fat. Say your pet was thin and they wanted you to add some fat. One of the thoughts is that vegetable oils, if you top dress them, result in a decrease in glycemic index. In other words, they stop that change of sugars and starches into blood glucose, which interferes with starch digesting enzymes. Okay, so a fat oil top dress can interfere. What's different and what can be done is a fat from something like stabilized rice bran and flax. That's a combination that I created called Healthy Glow. And it's just a healthy fat supplement. But what happens here is those fats, it's 20% fat, this product, are complexed with fibers and proteins. I'm sorry, it's 18, no, I think it is 20% fat. They're complexed with proteins and fibers, and they're water soluble. Okay, so these fibers and proteins bind with the fats, and it becomes a water soluble thing, so it's easy for the enzymes to get absorbed and the starch to get digested. So again, we can get fats into a pet diet, and just so that if anybody's interested, you can contact me about it. But this product is still available at stores that sell ADM feeds, and it is a protein and fat, mainly fat supplement, but it doesn't have added vitamins and minerals, so it can be added separately if you need to put weight on an animal, if you need to put it on, or if you just want the health benefits, which is what I do. I still use that product for my pets. My horses, my cats, my dogs all get some of this. Okay, again, you can contact me for that. Okay, so a couple of things about enzymes. Just like vitamins, people have always thought, well, okay, let's say someone doesn't have enough enzymes. We can test the fluids in their stomach, small intestine, something. We can test those fluids, and if there doesn't seem to be enough enzymes, we could say, okay, well, let's give them some more enzymes. That was sort of understood for years. But the huge thing that people didn't understand, and I'm just reading more about this now, is that larger quantities they are used for other things. They help with other things than just a strict deficiency. So that history is similar to vitamins. We used to think that you needed enough vitamin C just to prevent scurvy, which is that disease that the sailors died from when they weren't getting any citrus fruits and things. But now we know that we all need vitamin C every day, that we as human beings cannot make vitamin C, and that most other animals can, and that the sicker they get, the more they make to help themselves get better. So now vitamin C is one of the main treatments for any kind of diseases. So, that kind of concept with enzymes is happening also. So with chronic diseases, all kinds of them, and we know what they are, so I'm not going to list them, but enzymes are being used for all kinds of things that we didn't realize before. This is a specific book called Enzymes and Enzyme Therapy from 2000. And then he's written some other books before that. Um, the intro to his book was written by a person who I've read a lot about, Dr. Abram Hoffer, and he works with B vitamins, specifically niacin, and all the different things to do with vitamin B vitamins and vitamin C. And he had a psychiatry background. So he's one of those people that has helped us understand that a lot of the things that we think are psychiatry problems, mental illness problems, really also go back to deficiencies of these water soluble vitamins, B and C vitamins. And he talks about in Europe, a lot of studies have been published. And now this is in 2000. He's talking about this. This is a long time ago. There were already published papers by chiropractors, naturopaths, and physicians about all these extra benefits of enzymes. But no one has access to these papers. You have to pay into an association to get access to the papers. This is one of the problems we all still have. And it was in Europe, and it wasn't, much of this stuff wasn't available in the United States. But the key thing that makes all this work is the fact that there was a huge belief that enzymes are too large. Have you ever heard this? Enzymes are too large and they would be degraded by the stomach acid in the digestive tract. That's what we were taught forever. Not true. And if you think about it, whenever you think about when we talk about raw versus cooked, raw foods, the plants and everything, like an apple, has those enzymes. And that's why if it sits on the counter for a while, it'll start to go brown. The enzymes will work and it will start to degrade it. Okay. And we cook things because we don't want them to go bad. So we're kind of destroying those enzymes, right? So the difference between raw and cooked has a lot to do with how available those enzymes are. So this is something we have to get our minds around. Now, it's a great thing. We use and promote different enzymes and enzyme blends for that exact reason. We know they work. And most of the products for humans work for our pets. So we can go through our lineup of products that contain enzymes. Also, the probiotics and prebiotics and a lot of these different things are going to work really well for our cats and dogs because of the size. We can use them. And a similar digestive system. So we want to keep that in mind. So I just want to tell a quick story about raw and cooked. I was reading about a little trick that you can do. And I love broccoli. So I'm one of those ones that eats a lot of it. And I used to grow a lot of it when I lived in Minnesota. But so you cook your broccoli by steaming. I save the water then. And usually my pets get to have the water for, whatever nutrients happen to end up in there. But then what you do is you keep a little bit of the raw broccoli. So when you're eating your cooked broccoli, you top dress it with a little bit of raw broccoli, which then contains some of the enzymes. Just a little interesting way to think about it. Now, some people think about eating only raw food or a lot of raw food. The biggest problem there is that most plants in their growing stages contain ingredients that are trying to stop an animal from eating them. So they'll cause all kinds of different problems with the digestive system of animals. So most plants have things like that. They call them anti-nutrients, a lot of different things. So we have to keep in mind maybe a raw salad and then some cooked vegetables, things like that, kind of balance it out. But we want those enzymes. And if we don't have enough, we can certainly add some. Huge thing for people who have lost their gallbladder is that the bile is created by the liver and it just drips into the digestive tract instead of being stored in that gallbladder and only coming out with a meal. And that's in order to digest our fatty foods. It's a very good idea to get those from a supplement. Okay, so we have our enzyme supplements. Make sure that you're getting the one that has bile if you have no gallbladder. Just an FYI. And grazing animals like horses, they don't have a gallbladder. So that's why it's important for them to graze, keep on grazing. Okay, and just a brief thing, and this is from that new Dr. Wu text. He's talking about enzymes that are used in non-ruminant animal diets. Now, the main thing he's looking at here, when he talks about non-ruminant animals, that means single stomached. I don't like that term non-ruminant, but people used to call them, they used to act like they had four stomachs, which they don't. They have one stomach with four compartments. I mean, it's a complicated thing, but he's mostly talking about diets for poultry and pigs and things like that. So it's not specifically cats and dogs. However, this all applies because when we look at phytates, I was just talking about things that are in plants that interfere with the digestion of the nutrients in the plant. And one of those things is phytates. You've probably heard of them. They're the major storage of phosphates, which is phosphorus, one of the main things we need for our bones, a mineral we need for our bones. And sometimes 50% of the phosphorus in plants is stored in the form of phytate. So we need phytases to break that down. Okay, it's a complex, including that essential mineral, phosphorus. Okay, so that's one of the things we need enzymes for. Now, these three are all, I don't know if my pointer's working. Or yeah, there it is. These three are all sugars. The xylanases for xylose sugars, the glucanases for things like beta glucans, and the mannanases are also sugars. And these are things that break down sugar, and what they've done now in 2026 in this book is they've kind of renamed things. Back when I was doing my talk on sugars a couple years ago, hemicellulose was what we called one form of non like a fiber, just basically a fiber. There's cellulose made of glucose units and hemicellulose made of xylose units. Anyway, instead of calling them that hemicellulose, we now call them soluble non-starch polysaccharides. It doesn't seem to be getting better. So both of these two above, that's basically what they are. If you want to call them in a general term, they're soluble non-starch polysaccharides, or you can say which sugar they are using, glucose or xylose. Okay. And then the mannoses are for mannose. All right. And then the other kind of enzymes are proteases, and they break down proteins. So break them into amino acids and things like that. But the key takeaway here is this is another tool we have, because our goal is to get all the nutrients in that our body needs. But these are digestive aids, and it's a whole new way to look at them. And I think it's going to be pretty exciting going forward, some of the things that we're going to be able to do. Okay. For formulating our animal foods and feeds, as far as pet foods are concerned, there are several. I think there were 4 or 5 back when I was working, and huge manufacturing companies. We used Dones at the time for our pet foods. And so everybody buys their version of that food and labels it with their brand and sells it. Okay. So where I was working, we did not make our own pet foods. We did provide vitamin mineral premixes for the pet foods, but we didn't make them ourselves. However, what I did as the horse nutritionist, I actually designed and we created the foods there. So I formulated the actual entire feeds and supplements. But in pet foods, it's different. But I'm just going through what actually is the process. And these are pretty much common sense. You have to determine availability and cost of ingredients, what your customer wants or prefers. If you had access to an ingredient that your customers wouldn't buy or didn't want to feed to their animals, it's not going to work. You can't make it that way because people won't buy it. Then you have to look at the nutrient profiles of each ingredient. So for instance, I don't even want to, well, let's not talk about the ones I don't use. For instance, alfalfa meal. It's just the alfalfa plant ground up, and it's a great thing to feed to our grazing animals, to our ruminants and our horses and things in certain amounts. So we would look at, when we look at alfalfa, how much protein, how much of each kind of energy, of starches, sugars, those kinds of things are in it. Then a huge thing is we've got to look at the digestibility in that front part of the digestive tract. And it's called the foregut in grazing animals. It would be the stomach and small intestine and everything else. It's just terminology. It's foregut for grazing animals, because there are changes like with the ruminants, we're going to digest with bacteria in the beginning in the foregut in the stomach, and with the horses we're going to do it in the cecum in the hindgut. So it's very important, where do things actually get digested. Then we're going to look at the fiber content and the different types of fiber, the indigestible fiber, the digestible fiber. Also very important depending on the type of digestive tract. Okay, appropriate amounts of vitamins and minerals. That's the big one, because we know we need at least 60 minerals and 16 vitamins. So again, we've got to balance all that. That is a huge problem. Dr. Wu is saying that with the use of AI, it's helping them formulate diets. And again, we're not asking it to decide how much should go in. We're just asking it how to mathematically do it, right? That's a key thing. And again, processing methods. So different methods interfere more or less with the ingredients. We don't want to use processing that changes, denatures, or messes with ingredients, basically. However, processing is a big deal. I'm going to do a few slides on that because it's fascinating. What do we do when we eat food? First, we do mechanical, we chew and we break things down, and then we mix it with saliva, and then we add chemicals to it and all these things to break it down. But processing makes for instance, if I have a whole piece of something and I grind it, what I've done is I've done that mechanical type chewing for the animal. And that actually results in better digestion, utilization, absorption. So processing, and we're hearing all this, the buzzwords, ultra processed foods and all of this. Be careful, because processing itself is not necessarily bad. When they talk about ultra processed foods, what they're saying is we took white sugar, white flour, white rice, or things like that. We've already taken the vitamins and minerals, the protein, the fats, the basically most important nutrients out of it, and left just that sugar part or starch part. And then supposedly add a couple of things back in, because we know people are going to think we need to add things back in. That is not good. But taking that whole plant, or that whole fruit of the plant or vegetable of the plant, and processing it or grinding it does make it more digestible. It means you have to chew it less and things like that. So there are a lot of functional reasons to do that. People with bad teeth, people that need, liquid diets for one reason or another. Ultra preemie babies have to have their mother's milk put in through a stomach tube, so different uses for all those kinds of things. But processing isn't bad. Taking all the good stuff out and then adding a few things back is bad. Okay, so the food company does these things. They use a large variety of ingredients. They may have thousands of ingredients that are coming in. They're all tested, and they have to meet quality standards. I mean, I've watched this process. I've, worked at the pilot plant, created different feeds and things like that, and it's huge. So a company has to be able to do those things. They're going to maintain databases of the nutrient specifications of ingredients. So they'll get 4 truckloads of one ingredient in, and they'll analyze them. And they'll reject them if they're bad, and they go somewhere else, and someone else can do whatever they want with it. But this company is not going to use them if they're bad, if they have mold, if they have, things like that. They're going to maintain that database of the nutrient specifications. But then when you get another new several semi-loads of another, they are going to analyze them again, and they're going to change the values within the computer so that it's accurate. Then they're going to use all this current research on animal requirements. They're going to update tables and guarantees and ideas that they're going to use to create those feeds. And then here's a mix vitamins and minerals correctly for each class of animal. And the class of animal means, are they growing? Are they older? Are they exercising? Are they lactating? All these different things. Mix them all, figure it all out. And the liquids are, in a way, kind of have to be separate. We have to worry about our fats and our liquids if they're going into a pellet. We have to be careful how we combine them to get the combinations that we want. And then our trace minerals are in parts per million. So it might be 1 part of calcium in a million minus 1 parts of everything else. So you have to have equipment that's able to do that. And that's why we use premixes. So we'll mix all the vitamins and minerals into a premix. And then we put a certain amount of the premix into the complete pellet, because there would be no way that you could do it. You couldn't do it unless you have to work on those very small amounts and then add those to the bigger batch. So I guess the point here being is that there's really a lot involved in it. And it's why you have to pick a company that you trust, and you have to realize all the things that are happening here, all the things that are going on. I did mention this before. I'll just put it back up here again. Back in 1995, BHA, BHD, ethoxyquin, and we used tocopherols then, but now we use vitamin. Of all of those, we don't use these anymore. So times change. Those are things that, we just don't consider we want in our food or our animal foods anymore. So what is vitamin E? We know it's a powerful antioxidant. It's in a lot of the products. If it says D alpha, that's the natural. If it says DL alpha, that means it's all 8 isomers, different shapes and space, and our body has to convert the other ones to the natural to use it, which in humans, it's 1.36. You have to use 1.36 as much of the synthetic E to be the same as the natural E, and that's not a big deal. And you will pay more for natural E. Choose to do that or don't. The synthetic works, you just have to use more of it. But I happened to find out in my research by accident that horses cannot do that transformation very well. And so literally they were putting vitamin E like they do in all the animal feeds. They put A, D, and E, vitamins A, D, and E in all the animal feeds. But they weren't putting enough in the horse feeds and it wasn't doing any good. And when I was researching it, I realized that we had to use the natural E. And when we did that, we had huge improvements in reproduction, performance, just about every parameter you can imagine. And this is why I'm a big fan of vitamin E. Again, it's a natural preservative and it's a nutrient within the body. It works in the fat soluble tissue, so that's in the membranes around each cell. It helps with immune response. That's kind of important lately. Exercise endurance, exercise tolerance. They can work longer. Improve nerve and muscle function. And I said the D alpha is more effective. And if we're adding fat to anything, and again, we have 2 sources of energy, for energy for all animals and people. It's carbohydrates, and they can be either sugars and starches or fibers, or it's fats. And we've gone away from a lot of the sugars and starches and gone to fat. So whenever we're doing more fat in our diets, and this works for pets too, I'll get there in a minute. Very important to have that vitamin E in there. So some people talk about it more or less, but it's pretty important. I think I'm going to skip over this because we're running out of time here. I did talk about this. Whenever we're doing an example of a pet food, I have a dog and a cat food here. We have to look at the guaranteed analysis, which is the requirement for each of the things like protein, fat, all the vitamins and minerals and all those things. And then we have to look at the ingredients. I do want to make a comment here. We basically look most at the first 5 ingredients. Here we have beef meal, whole grain brown rice, and whole dried peas. 1, 2, 3, 4, 5. Okay, so those would be the main ingredients. In that respect, I don't have a problem with those ingredients. As we go down, we have canola oil. No, I don't want that in my food. I don't want the grain sorghum either. Sorghum has anti-nutrients. But you're going to take your dog food label and you're going to look through all that. And what I recommend is people follow the same good food, bad food things that we do for ourselves, right? We don't want the gluten. I try to get a grain-free pet food. And then I look at some, what are the other things that are in this pet food? And as soon as you do a grain-free, you're in better shape. But here's another huge thing, and I always have to say this: cats are not small dogs. Cats are obligate carnivores. I was in a pet food store the other day, and they had just come out with a brand new brand of cat food. And it was sitting in the aisle, and they were going to really sell it. It was going to be great. Well, cats need like 36% protein in their diet, and they don't eat vegetables. And I mean, their main diet it's certainly not grains, and it's not really much for vegetables either. Okay, they're animal eaters. And the number 1 ingredient on that, and it's not this one, but the number 1 ingredient on that cat food that I saw was corn. You can't do that. You can't feed corn-based diets to cats. Doesn't work. So they're going to find that out one way or another. Now this one has chicken meal, fish meal, and then it goes to lentils and peas, sweet potatoes, salmon, chicken fat, So, and look at what it's preserved with. Mixed tocopherols, which is vitamin E. How about that? That's pretty cool. So again, we've got to look at these things, and a cat has to have a lot higher protein, and they aren't going to want to eat things that are made with grains, mostly grains. So for sure, with your cat, be more careful even than you are with a dog. And key, it's all got to be balanced. Okay, so if you use a commercial pet food provider, it's their job to follow the rules set out by the government to make sure that the pet has everything it needs. But that other cat food that I just found that starts with corn, that does not follow AAFCO rules. They're the Association of American Feed Control Officials that I've talked about in previous talks too. They set the guidelines, and that would never have met those guidelines. So you can look on pet food bags and see if they do. Okay, we have specific products that work for pets. We have Arthrodex and Perpetual, and we have lots of the human products. And I did talk about this before, but again, any of us can answer questions about that on which things are going to be the best for your pets. I'm going to quickly run through this because it does relate to our pets, even though we're going to talk about grain disorders in people and horses. Grain associated disorders, horses have a huge issue with it. And one of the main things I did was take as much grain as I could out of the horse feeds, and it was very successful. But mainly grains themselves have ingredients that horses cannot digest very well. Remember, there were no grains in the history of the horse. So that, it's a relatively new thing. And what this all started with is humans, and this is all about things like diabetes and things like that. Things that have been labeled those kinds of disorders are carbohydrate and insulin syndromes. Okay, lack of ability to digest and utilize things that have a lot of sugar and highly digestible starches. So all of this came in human syndrome X, then it was equine syndrome X, then it was human metabolic syndrome, and then equine metabolic syndrome. That was pretty quick right there, 3 years, I thought. This is the World Health Organization. So we started talking about equine grain association, equine grain associated disorders in 2003. But the reason I wanted to bring this up is that as people feed their pets like people, this is happening to the pets too. Pets are getting those same disorders that people get, and there's no reason for that. They cannot be fed things. Even if people are eating a bad diet, that doesn't mean you want to give your pets a bad diet. So that's a big thing. Okay. And I don't need to go through that. That's mainly the horse part of it. Okay. And then this is my last major thing. Food or feed processing and growth. Remember, I talked about you can grind something and get better absorption and performance for the animal. That means it's processed, but that's not a bad thing. So here's one example. This is a 2005 study that was published in the Equine Science Society Proceedings in the journal. They have seminars every year that I went to many of those for years. They took 8 weanling standardbred horses. Those are the kinds that do the long trotting standardbreds with a cart behind them, for those of you that are not big horse people. 3% of body weight and 2 meals daily. But here's what they did. They took 50% alfalfa cubes and 50% what I call a sweet feed, corn, oats, and molasses and that kind of thing. And that was a popular thing to feed back in those days. It isn't anymore. We don't feed those much anymore. For diet 1, they took all that and ground it and mixed it and repelleted it. So it was all pelleted together. In other words, they processed it. So the particle size of everything, the alfalfa, the piece of alfalfa in the cubes, all the grains and everything was mixed, and they ground it. And then the other diet, they didn't do anything. They just put the feed in one container, the cubes in the other container, and let these, year-old horses eat it. Okay. And then they did the 3-week switch back, which means the first group was on the first diet at the beginning, and then they switched them. So same horses, diet 1 went to diet 2, diet 2 went to diet 1 in a 3-week design. This is a quick and easy experiment. But this is what happened. The ones that ate the pelleted diet, if you look at this, this is the amount of gain in body weight compared to the amount of feed fed, and this is a percent. So if you look at the amount of gain, this is almost 12% on the pellet. In other words, the processed part. And this one is roughly, it's hard to tell. I think it's about at the 8. So it's somewhere between 8 and 11%. Okay, that's your savings just by processing it. And this just shows it in average daily gain in pounds. You can see it's the same ratio. It's just, I mean, that's a fourth to a third better gain for what you're doing. And that goes across things. So whenever you're feeding like a pelleted feed to a horse, of course, the key thing is make sure you're using good ingredients, because the problem with pelleted feeds is that unscrupulous people can put a bunch of junk into it and it's not good. Okay, so my digestion summary. Every animal has a different digestive system, and everything they eat has to get processed through there. Dogs, cats, horses, humans, all the animals digest things differently. Our forage is the natural feed of the grazing animals, but even that is deficient. Animals can't live on just grass. Okay, optimum amounts of nutrients can promote health and performance beyond the minimum amounts, and we have to do that. Okay, and all of these digestive and metabolic disorders that everybody's talking about are associated with foods and feeds, which is the main point we're trying to make. So as I like to say, the opposite of disease is nutrition. And that's one of my foals when he was a baby. All right, that was a lot.
That was great. Thank you so much.
Thanks, everybody. Wow. You got to go back and listen to it a couple times, though.
Yes, definitely. That was brilliant. We got a lot of good comments for
Thank
you. And we have a couple questions. So
Okay.
I'm going to bring Phyllis on.
Hi, Phyllis.
I can ask you.
Hello, Dr. Judy.
Hello, how are you?
Just right. And we've
Good.
got some comments coming in from YouTube, also a question.
Okay.
ZZ Captain says, we love Dr. Reynolds. She's the truth in the kingdom of lies where truth is treason.
Wow. Thank you so much.
And we have Yvonne saying, great work, Dr. J, on the stabilization choice when you were talking about the rice bran. And she says it's really a great nutrient-dense food source for animals and humans. Let's see. And then we have a question from Bruce. He commented, Richard Renton, Dr. Dirt, as we know him, has shared his cat is 29 years old. And Bruce wonders, what do you think is the reason? Is Arthrodex and gluten-free cat food enough? And I know you have already gone into some detail about ideal cat foods, away from the emphasis on grains and so on. What would you like to add to that?
I think, first of all, nutrition is huge, and I have family members, and I mean, a lot of people in my family are cat people, and we have some very old animals that have been in our family. So, and I mean, a lot of this was before I knew a lot of the stuff that I know, but yes, paying huge attention to the nutrition, doing veterinary care as needed, but not as much as some people think. I mean, some of that's been overdone too. And then just the plain loving and caring for our animals. It's huge. One of the main things, I was just talking to a group of people, what was it, 2 nights ago? And they said, well, what's something really important that you would like to say that you think is important that you would talk about if you had time to? And I said, the fact that when I was a kid, animals lived a third as long as they do now and things like that. And they were just, what? That's what it is. It's that with knowledge, we have better nutrition mainly. We have some forms of better treatment in the veterinary field. And again, I'm a nutritionist. The veterinarians do the surgeries and you know, fixing car accidents, all this kind of stuff, like doctors do. And they are experts at their field. And there are things that they use that have their place. But I think it's that we can put our fingers on. But it's also just when you love and care for your pet, that's part of it too. So yeah, that's a pretty long life for a cat. I bet my mother-in-law could beat it, but I would have to ask her because she's had cats a lot for a long time. So anyway, yeah.
Thanks so much. I'll go back to you, Ruth Ellen.
Thank you, Phyllis. And we're going to bring on Mary, who has her hand up with a question.
Hi, Mary.
Hi, Dr. Judy. I'm bringing in a couple questions, well, a comment and a couple questions from Keely. She says, I so appreciate Dr. Judy's candor, truth spoken about AI and being able to vet all the information based on scientific resources. Her questions are, when looking at pedigree pets and others, are there lab tests that you recommend and why?
Okay, when she's saying pedigreed pets, is she meaning breeding dogs specific? Is that what she's talking about?
Yes, is her answer to that.
Okay. And is that for show purposes, things like that? Are we talking about maximizing nutrition and looking at lab work to do that? Is that what she's asking?
I may Old English Bulldog Show, Dogs and Maxi Nutrition.
Okay. Okay. Kind of an in-depth topic, because here's the thing. Most people believe that you can draw a blood sample and find out all kinds of things about nutrition. Not true.
Mhm.
And here's why. It's easy to draw blood, so we do it. Doesn't hurt that much. You can get blood just about anytime, anywhere you want. But the purpose of blood is to get the correct nutrients in the correct amounts to every cell after being absorbed through the digestive tract. And so the blood, by definition, has to have certain concentrations of everything in it. And then that has to get where it needs to go. So for most things for nutrition, and I'm going to put my pharmacist Ben hat on right now, and I'm going to say, I don't know which one of us said it first, but you got to do a dietary analysis. Okay. You have to do a dietary analysis. All of nutrition, you decide what you ate to figure out if you have enough, because the blood has to be controlled. And by the time you run out of something in your blood, you're in deep trouble, right?
Yeah, for sure.
And there are things like you can do liver biopsies. Nobody wants to do that. So things like that can help with nutrition. But as far as actually finding things out from lab tests, not the best way to do it. Now, I have a little bit of insight on the whole lab test thing, because my daughter, who was on with me the last time we did pets, her real job for over 20 years was she was a lab technician at a pathology lab where she worked nights in the hospital and ran blood and urine samples.
Oh, I think she froze.
She froze. Hopefully she comes back.
Okay. Hopefully she'll come back in a second and finish her question. answer, and I don't know who's doing that, but they need to stop. Um, okay. I was hoping she would come back.
Yeah, looks like she got booted out. So
Maybe they have a storm. All right.
okay.
So thank
we
you
got-
for asking your questions, Mary.
Absolutely, absolutely. We'll hopefully get the
There's-
rest offline.
Oh, here she is.
Okay.
Sorry, everybody, that
That's
my
okay.
internet just dropped.
That's okay.
So that's the first time that's happened on one of these live shows, I just realized. But it
Right.
happens once in a while. Okay, so how much of that did you hear? I was talking about my daughter doing lab tests and how, if something goes wrong, yes, you need to do lab tests,
Yes.
but it's not a good idea to base a lot of the issues to try to base it on a blood test. Okay, because blood is that's not its purpose,
Mm-hmm.
right? Does that make sense? I mean, it's easy, but it's not the right thing to do. So
Right.
again, you got to give me an example of a pet that comes in with some kind of a specific problem. Or I could do one. Cat seems to be tired, doesn't want to get up, doesn't move around, seems to be lazy, whatever. You can do some blood tests and you can check for iron. You can check for ferritin,
Mm-hmm.
some things like that. And you can check for white blood cells, because if they have high white blood cells, they probably have an infection. Things like that. Those are basic logical things, right? That make
Yeah.
some kind of sense. But most nutrients are not, you can't do it from the blood because the blood has to be controlled. I mean, that's just a simple way of try to get your brain around that concept. Okay. Now, to maximize nutrition, again, we look at everything we can about the breed. If they have any, there are some genetic things that animals can have, that pets can have, individual people can have. I did my PhD work on a genetic mutation called hyperkalemic periodic paralysis. And you can do a genetic test to find out if they have that. And what happens is they can drop dead from too much potassium because they can't, they have a leak in their sodium channels in the muscles. It's a complex thing. But there are genetic diseases that you can work around with nutrition. Okay, that's the methylfolate thing too. That we've talked about those in some of my other talks too, where you need to move methyl groups around to have things work the way they're supposed to. So, if there's a problem, yes, we probably would want to work with a vet, get some blood work done, but we also want to work with a nutritionist and see what's going on by looking at the diet.
Okay.
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 I think just a follow-up point, she's asking, so a healthy animal is one without physical failure? So if it isn't broke, do not fix it?
Well, I wouldn't look at it that way either, because the average person thinks you can eat whatever you want and feed their pet whatever they want, and average is not good.
Yeah.
Average, I mean, if you look in a book and it tells you that the average amount of XYZ in your blood is this, I mean, I shouldn't even say blood because again, it's controlled, but does that make it good because most people have that? No, it doesn't make it good. It just makes it
Right.
average. It just
It's
means a
average.
lot of people have it in that amount, but that doesn't make it good, right? So we
That's
are
right.
looking for optimum nutrition. And that one chart, or the one that I use all the time, where if you don't have enough of a nutrient, you die. And then you get a little more, and then you got the NRC, the government amounts to keep you from obviously being sick of that disease, whatever. And then you go up the top and you've got the optimum amount. And in that case, you want the cheapest amount of optimum. You don't want to feed extra stuff. But if you feed too much and it gets down to the bottom and then you're on the other side, I should have the graph up to do it, but I'd have to go digging through my slides to find it. But each nutrient, you need the right amount, not too little, not too much. You need it just right. You know, like the Three Little Bears or whatever.
Right, right. So if you think about that for, I mean, we kind of talked about it for animals. Her other question is the same question for humans. Do you think there are, lab tests that you would recommend for humans?
Well, what really concerns me in the human field is that they're testing things that are irrelevant and harmful. And the whole concept of good and bad cholesterol is still really bothers me, because
Yeah.
cholesterol is one of the most important things you need. It's been proven that anywhere from 200 to 350 is much healthier than going below 200. And yet everybody's out there testing for that. So when people try to get you to take a whole bunch of tests and then the result means you got to take a whole bunch of medications, that's where you run into the problem.
Yeah.
And so I
Gotcha.
think we need to be our own doctor. I have two books that I've had for a while. One is Be Your Own Doctor, and the other one is Be Your Own Veterinarian. And it's like, what are the things that you can do as an animal owner? You know, you can take the temperature if you think something's wrong. You can understand the breathing rate, your respiratory rate, the heart rate, a lot of these different things. You can understand, you know, dehydration. There are a bunch of ways to tell if your animal's dehydrated, things like that that you can do yourself. Obviously, I mean, I have to be careful. I don't want people to not go and get help when they need help.
Sure, of course.
But we all have to make a judgment, and I firmly believe we are the one responsible for our own health. Because if something goes wrong and we die, we're dead and they go golfing.
Yeah.
And it's who's got the skin in the game. So that's where I'm looking at. We have to take responsibility for what we do. And, it's part of basically standing up to authority.
Mm-hmm.
I mean, I was always a very motivated person to learn things. And I was kind of an outsider because I was interested in sciences as a woman.
Mm-hmm.
And it was all men. I mean, there was a science club, there was a biology club, and all those, and it was all guys except me. Well, so be it.
Yeah.
So you have to kind of go your own way, do your own thing.
Completely understand. I was in a similar situation.
Yep.
Just the last point is on metal testing. Would you think there are options for that, or how would you evaluate metals, either, I guess, in animals or humans?
Yeah, that's a huge thing that people are looking at contaminants, metals, and there are good resources for that. There are specific people. I could make a list, or some different places you can go and do it. A caution there
Mm-hmm.
is that some of the people that are out testing for things don't understand that you have minute amounts of things like arsenic that are actually important and necessary. It was shown a long time ago that a tiny amount of arsenic stops, I don't know what word to say, but if you have that small amount that you need, there are big C word blood disorders that you won't get.
Gotcha.
Right?
Yeah.
So there are we need tiny amounts of things. Selenium is hugely important. But originally, there were plants out in the Western United States that would absorb huge amounts of selenium. And if animals couldn't find anything else to eat, they'd eat those selenium plants, those ones that concentrated the selenium, and they would die. There's a funny story about Custer. The people that were trying to help him didn't get there because their horses ate too much selenium and their hooves were destroyed. I was told that story by a guy, one of the mentors, when I was in college, the older nutritionist, Dr. Harold Hintz, used to tell that story about selenium. So people misunderstood. When something starts out seeming to be bad, then people think it's always bad. And that's
Right.
what's so difficult, is that, yes, we need selenium and we need a certain amount of it all the time. And it's one of the main things that we have to put in animal foods. Just like salt, you got to have salt. Yeah, too much salt, you die, but you got to have salt. So as far as toxic minerals, yeah, there's a bunch of stuff going on there now. There are different ways to test for it. And I think it's something people should consider, especially in children that are having all these different issues.
Yeah.
There's
Yeah.
so many issues in children that are heartbreaking.
I agree. Well, I
Yeah.
appreciate you coming back on
Thank you.
and taking the time. We definitely will be in touch with you. Actually, my daughter's ready to talk, so
Yeah.
we'll come back and do that
I
later.
look forward
I'll
to
turn
it.
it over.
Yep.
Great. I'll turn it back over to Ruth Ellen.
Thank you, Mary and Keely, for those great questions. Do you have time for one more question,
Yeah,
Dr.
sure.
Judy? All
Yep.
right. AJ? You're muted.
Hey, AJ.
Hey, Dr. Judy, how are you?
I'm great.
Fantastic. All right, so a couple of things, but first, I'm just going to ask Olga's question on YouTube. Can we do a fur analysis on the cat?
That's a good question, but you run into the same issue. This was a big thing when I was working with horses, because you can have one horse that's half black, half white, spots all over, and you can analyze the hair and it's totally different. And with your pets, the hair is different colors. Now, what Dr. Wallach does with the hair analysis that he recommends, it will give you heavy metal concentrations. And you follow the book, the recommendations in his book, the
Rare Earths
what's it?
Forbidden Cures.
Rare Earths Forbidden, thank you. Rare Earths Forbidden Cures, and you follow that. But what you cannot do is look at that analysis and find out if the body's store of the basic minerals and stuff that you're supposed to, that you're looking for. Again, hair is not hair, your body's getting rid of hair, and it's doing that to protect itself. The hair protects the body in certain ways, and you're getting rid of stuff. Now, toxic stuff, if you're getting rid of toxic stuff, that means you've got a toxic problem, and you can find out which minerals you're having problems with. But it is not a good way, that's my humble opinion, not a good way for other things, just because of the fact that you can have different hair colors and things on the same animal, and you're going to come up with different results. Okay, does that make sense?
Yes, thank you for that. And then I need some clarity. You said earlier there are genetic diseases you can work around using nutrition. Now, we talk and you use methylation as an example, that people have difficulty, a large part of the population have difficulty with certain vitamins because they need them pre-methylated. They're not bringing the methyl groups or able to process the nutrients properly. And
Correct.
so our standard contention is that there are no genetically transmitted diseases. And then secondarily, if a cell is damaged, it's from lack of oxygen, toxification, or lack of nutrition. So I'm looking for a little clarity on what you meant by genetic diseases.
Okay, if you are missing an enzyme for the methylation process, that's a specific gene that does not have the ability to make that enzyme, which is a protein. Your genes are blueprints to make the proteins that then become that enzyme, that fold correctly to become that enzyme. But the reason that happened was because of a lack of nutrients when that cell was formed.
Fine.
Got it? Does that make sense? Does that make sense?
Just as long as we're on the same page.
Yeah, yeah,
As long as we're
Yeah.
on the same page.
yeah. No,
Alright.
it is, and again, when I say work around it, with my research, the horses that had this mutation, and you could have one or two. Remember, you get one from each parent, so you could have one or two. It was actually a co-dominant. So what would happen is a horse could have one of these and be relatively healthy, but if they had both, they were very sick. They could survive, but those are the ones that, might drop dead in the stall. But here's what it was. The muscle cell membrane sodium channel was defective. So it would leak and fire, and a whole bunch of potassium from the inside the cell would go into the blood. And when an animal has too much potassium in the blood, their heart stops. You use a high potassium solution for euthanasia of animals. So it was a defective gene in the muscle cell membrane that was passed down as a co-dominant. But what we did to make sure that those horses did not die of it was we fed them a really low potassium diet. You see what I'm saying? We manipulated the diet to prevent the mutation in the cell from working.
Okay, so let me ask you this. If the mother were properly had the right nutrients when that horse fetus was being developed, are you saying that this genetic issue would have occurred?
It would not have.
Okay.
Right?
Then we're all
basically it's the genes that the mother or father pass at conception. If those cells, the egg cell or the sperm cell, have a problem with the DNA in that exact two cells, then at that point, that animal or person either dies because it's such a severe defect that it can't survive, it can't grow, or it grows to the point where it can even be born, maybe even live for a certain length of time. But in the case of that mutation, somehow or other, somebody fed them a high potassium diet, or when they were sick, gave them an IV that had potassium in it instead of just sodium chloride, and the animal would drop dead. It's just an example of one mutation. It was interesting to me too, because there were multiple other, in humans, there are multiple similar sodium channel disorders. So I wasn't just learning about horses, I was learning about people also in that case. And the good news is that once we figured out what the problem was, to start out with, the breed associations did not want to make those horses ineligible because they were valuable animals. There was a lot of money in these animals and they didn't want to do anything. But then after some time went by and they realized that these horses were not healthy, they finally said, okay, so many years and you can no longer register them. And so the main problem that I helped solve is almost gone. Right? So if you are a breeder of a type of animal that has defects like deafness or, a lot of different things, most of us would consider it unethical to continue to breed those animals. Right?
I hear you.
Yeah. So what happens then is people decide, do I want to keep doing this? I could get myself in real trouble by just making a comment. If an animal cannot breed naturally because it's a bird and they want a really big breast on it, so you got to artificially inseminate every one of those forever, is that ethical? If a dog has such a wide, deformed chest and legs, that it always has to be delivered by cesarean section? Is that ethical? Those are things that humanity has to decide.
All
Right?
Well, thank you very much. Thank you very
But
much.
what we don't want to do is do that with people. See, that's where the problem comes in. That's where the problem comes in. Right?
My mouth
Yeah.
is shut. Just give everybody some nutrition though.
Yeah.
Yes.
Well, again, but that's what the whole thing is about. If nutrition is what I do, it's what most of us are doing to try to help people. So if you already have a child or a person with a, defect in methylation, and we can help by providing the other form as a nutrient, awesome. That's what we do. But what we don't want people to think is that everything is determined by your genes. Once your genes are determined, once your genes are there, you're out of luck for everything. Because that's what they tried to do. They tried to find a cure for everything, all the chronic issues and chronic diseases and everything. They tried, once they learned what genetics was, they figured out what it was, and then they figured out the whole genome of a bunch of different species. And then they decided, everything must be genes. And it isn't. It isn't. But nutrition affects the formation before it happens. And then, you can make money selling nutrients, but you can't make as much money as you can selling whatever to try to fix it later. So that's the whole.
I know what you're saying.
Yeah.
I know what you're saying.
Yeah.
But that's for another conversation. Maybe
Well,
the one that you and I
yeah.
have tomorrow.
Yeah. Everything does. Yeah. Yeah. I got some interesting information for you, AJ.
All
Too bad you
ears.
couldn't. Too
Yeah,
bad
we'll
you
talk
couldn't hear it
offline.
the other day. I know, tease,
We'll
but whatever.
talk offline.
Thank
Thank
you
you.
so much. Thank you, AJ. And thank you, Dr. Judy. And we did go
Thank you.
over quite a bit, and I appreciate all of your time and answering the questions and everything.
Thank you.
And we look forward to having you on again. So please let me know what you want your topic to be so I can
Okay.
do my promote it and everything, get you all set up.
Sounds good.
All right. So I just want to I have to say this program was for educational purposes only. It was not meant to treat, diagnose, or cure or replace any of your replace your primary care physician or your pet's veterinary physician. And also, if somebody invited you to this program, please get back with them. And if you have questions, please email questions@dailywithdoc.com. And if you would like to speak to a certified holistic health coach, then please call us at 855-949-3377. Thank you, everyone, for joining us today. And Dr. Judy, again, a huge thank you. We got lots of comments, and thank you for doing that deep dive, Keely says. And we just, every time you're on, it's amazing. We learned so much. So thank you, everybody. So I'm going to go ahead. See you. If you have to go, go ahead. All right. So we have AJ on the screen with us. He is our digital marketing director, and he helps get us on all the different platforms, sets up websites, domains. Like, I can't even tell you everything he does. He does a lot, and we appreciate him a great deal. And then we have Mary, who is a co-host, and she is helping with letting people in and following the chat and bringing questions from the different platforms. And we have Phyllis, who is responsible for helping Dr. Wallach get on the radio. So bravo for that, or none of us would be here. And she's also helping in the chat and bringing in questions from the different platforms and responding to people and posting things that need to be posted where they need to be posted. Thank you so much. You make my job way easier. Thank you. And then we have Marilyn, Miss Speedy Fingers, who is doing dictation in the chat. And she really does well because she gets almost every word. I don't know where you learned that skill, but my God, bravo to you. And then we have Albert, who is from South Africa, and he is a gentleman and a gatekeeper. He just has a special thing, a way about him. I don't know how to describe it. And he will be the one answering the phone if you call the hotline in the middle of the night, because he's asleep. He's awake when we're sleeping, and we are grateful because it's like 9 or 10 o'clock at night for him or later. So thank you for all that you do, Albert. And again, my name is Ruth Ellen Sanchez. And Rebecca, I hope you feel better tomorrow, because I just want you to be good. And it was my honor and pleasure to cover for you. And we will see you next week with some amazing guests and a lot more information. So thank you so much, everyone, and have a beautiful day. Oh, remember to be kind. Be kind. You have no idea what somebody is going through. They may be happy and smiling and acting like the world is great and caring for an ailing patient, a family member at home. They might be going through something themselves that they can't talk to you about with anyone. So just be kind. Bye, everybody. Have a beautiful weekend.
This program is for educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. Statements in this program have not been evaluated by the FDA. As an empowered individual, you do have options available. We're honored to continue and share the teachings of the founding father of science of epigenetics, Dr. Joel Wallach. This program is for educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. Statements in this program have not been evaluated by the FDA. As an empowered individual, you do have options available. We're honored to continue and share the teachings of the founding father of science of epigenetics, Dr. Joel Wallach. This program is for educational purposes only. The content is not intended to diagnose, treat, cure, or prevent any diseases, nor is it intended to take the place of your primary care physician. Statements in this program have not been evaluated by the FDA. As an empowered individual, you do have options available. We're honored to continue and share the teachings of the founding father of science of epigenetics, Dr. Joel Wallach.